This video lesson is going to cover similar solids. So at the end of this lesson, hopefully you can use proportional reasoning to calculate changes in area and volume of similar solids. Now, as a reminder, please use this space on the left to write down any questions that you have, either for me or for yourself. All right, so let's take a look. Similar solids. So remembering what similarity is all about, we're talking about two solids that have the same shape but not necessarily the same size. So if we have the scale factor, and I'm going to say that this is also known as the ratio of two similar solids is A to B, then the ratio of their corresponding areas is going to be A squared to B squared. The ratio of their volumes is going to be A cubed to B cubed. So looking at this figure here, if I'm given the ratio of corresponding areas, I can go from this by taking the square root and get A to B, like we just said, or I can take this and cube it to get the ratio of volumes, A cubed to B cubed. So it's just another way of looking at the same thing we have up here. Now, the thing about this is you always want to be very aware as to what we're talking about. So when I say A to B ratios, we're talking about things like length, width, height, perimeter. We can also be talking about things like a radius or a diameter, circumference. I can be talking about a base. I'm going to say base edge just to make sure it's distinct. And I have a feeling I might be able to add to this list tomorrow, so make sure that you leave room because I might be adding more words tomorrow. A squared to B squared ratios, these are the areas. So I might be talking about a base area. I might be talking about a lateral area. I might be talking about a surface area. But no matter what, these are all areas. A cubed to B cubed ratios are very simple. We're talking about volume, and that is it. There's nothing else about that. All right, so just to kind of cover what these are different ideas are, A to B ratios, these are things that we would measure with a ruler. A squared to B squared ratios, these items are things that I could paint or maybe wrap in wrapping paper. A cubed to B cubed ratios, we're talking about volume. So this might be filling a container with water. All right, so this at the bottom of the page, moving along, is all about just understanding how to use your calculator and how to transition from one type of ratio to another type of ratio and back again. So if I have A to B, this direction is probably the simplest version, the simplest way to go. So if I have A squared to B squared, I'm going to take the first number and square it. I'm going to take the second number and square it. So that means I'm actually going to have a final answer of 4 to 9. Now keep in mind, sometimes when we write these, we're actually going to write them like a fraction. It's just in terms of space, I'm going to leave it like this for right now. But mathematically, I probably will be writing them as fractions. Looking at the second one, we have 3 to 4. So again, I'm going to square the first number, square the second number, and that's my A squared to B squared ratio. Now going back to the first one, let's fill in the A cubed to B cubed. Now don't make the mistake of coming here. We want to go back to the original. So now I need 2 cubed to 3 cubed. Well, 2 cubed means 2 times 2 times 2, so that's 8. 3 cubed is 3 times 3 times 3, so that's going to be 27. For A cubed to B cubed for the next one down, we're going to have 27, and 4 cubed is going to be 64. So now looking at 9 to 25. This is a ratio of A squared to B squared. So to go in this direction, we want to take the square root. So what's the square root of 9? Hopefully you guys are saying 3. What's the square root of 25? Hopefully everyone recognizes it's 5. And then from here, we're going to go from 3 to 5 to A cubed to B cubed. So A cubed is again 27. b cubed, or 5 cubed, is going to be 125. Right now would be a good time to pause the video and try this one on your own. Hopefully right now you're resuming the video. And when I go in this direction, again, I'm going to take the square root of the 16 and the 49. So that gives us a ratio of 4:7. Now I'm going to take these two numbers and cube them. So 4 to the third power is 64. 7 to the third power is 343. Now, going from this one, we want to go all the way from here to here. To do so, we're going to use the cubed root feature on your calculator. Now, you may know what the cubed root of 1 is or 8 is, but if you don't, this is when a calculator can be very helpful. So to do this, you want to press the math button, and then the fourth option down is the cubed root button. So now I'm going to type in the cubed root of 1, which hopefully is obvious, it's going to be 1. Now I'm going to do the same thing for 8. So the cubed root of 8 is 2. So over here, I have a ratio of 1 to 2. And then when I come back in this direction, I'm going to square the values. So I'm going to have 1 to 4. Now coming back this way, this is again a good time to pause the video to see if you guys can do this one on your own. So when we go from a cubed to b cubed again, we're going to have 1, and the cubed root of 64 is going to be 4. And then coming to a squared to b squared, I'm going to square the 1 and square the 16. Now this may seem more algebraic, but we want to have this type of skill down when we go on to the next page. So please continue with the next video.